Today we will learn about transformations of the quadratic function f of x equals x squared. Um, this is the mother function, right? This is where all functions come from. Mother Earth, Mother Africa, mother function. All right, and today we're going to be shifting these mother functions, also known as parent functions. But I feel like fathers are great. My dad is the best. I'm a daddy's girl. But mothers just kind of rule. So we're going to call it a mother function instead of a father function, although you get alliteration with father function, father time, father function. Yeah. All right. So I just want to point out a couple little characteristics of the mother function, the quadratic function, the parabola, what that graph looks like, right? So it is over 1 up 1 from the vertex. It is over 2 up 4. It is over 3 up 9. It is over 5 up 25. It is over 6 up 36, 7, 49, because the x value is squared to get the y. And it's also reflected across from each other, right? From the axis of symmetry, which goes through the vertex. The x of the vertex is the axis of symmetry. So first things first, we're going to learn how to do a quick shift, and that is to reflect, right? So we're going to first learn how to reflect the graph. And we actually know this already. When we worked with constructing the parabola in our last unit, we said that if we had a parabola with a negative a, right? So f of x equals negative x squared. That would make the parabola point down, to open down, i.e. to reflect. So what I kind of like about this is, I did my little picture because I'm trying to be fancy. You click transform, transformations, and we just mirror it. Okay, let's try that again. We pick transform and we just mirror in the x-axis. What is happening? Why isn't it doing what I want it to do? All right, let's flip it then. Flip it in the x-axis. That's not what's supposed to happen, by the way, and it will just take it down to here. Okay. So the same parabola would be created with the same size over 1, down 1, over 2, down 4, over 3, 1, 2, 3, 4. Hold on. Let's get this bad boy where it's supposed to be. There we go. Over 1, down 1, over 2, down 4, over 3, down 9, over 4, down 16, etc. And just like that, you've reflected it just by making it a negative a, right? Standard form is, standard form is f of x equals negative ax squared plus bx plus c, and to make it negative we just change the a. And by the way, this is also really an extension of the basic x squared. All right, so next we are going to look at how to shift this mother function left and right. Okay. And this also kind of goes with the whole idea of me choosing mother instead of father or parent. You probably see parent on a STAR test, or a test in general. But yeah, I make sure I say parent so you know, but I like mother function. Okay, so if we want to shift this mother function to the left, then we are moving it along the x-axis. Okay, all right, so if I want to shift along the x-axis, i.e. if I want to shift left or right, I need to affect the x in the equation. All right, so if I make changes to the x, I will make changes to the parabola along the x-axis. All right, and the way I do that is I take that x squared and I find a little space in there and I say, hey, I want to do something to this x. I want to move it. But here's the deal. If I want to move it to the right, I do not choose plus. I choose minus. Okay. And if I want to choose it, move it to the left, I do not choose minus. I choose plus. Okay. And that's because the original format of the equation to make a shift left is minus a number. So if you input a positive number, you are moving it to the right. But if you input a negative number, that negative will change the negative that's there into a positive and move it left. But at the end of the day, what you're going to actually see is a minus and a plus. So you might as well just see it like, hey, if I see minus a number, move right. If I see plus a number, move left. And unfortunately, the way that I think of this and that I'm also going to share is that we're talking about mothers who are women. And women have a tendency to say one thing but absolutely mean something else. You know, we've been talking about X and Y being in a relationship, and so the woman is like, yeah, that's fine, but really she's thinking, I would, you better not do it, right? So she'll give you this idea that everything is cool, but really it's not. And that just happens a lot. It just does. You know, or your parents, or like my dad would be like, well, my mom, excuse me, would be like, uh yeah, you can stay out until a certain time. And I just kind of knew that that wasn't true. Or she would be like, yeah, I can't think of really good examples. I just know that I couldn't always like depend that if you say this, it was going to happen. Moving on. So, what does that look like? I'm going to have to erase some of these here in order to give you that visual, but don't forget minus makes me go to the right because it's not what I'm thinking. It's not what I'm saying, it's what I'm thinking. So if I want this graph to move this way, okay, I want it to move this way 6 spaces. I want it to shift to the right 6 units, 6 spaces. That means I want it to go 1, 2, 3, 4, 5, 6. Okay, I want this graph to move 1, 2, 3, 4, 5, 6 spaces over. I would change the graph by getting inside that lady's head, mom's head, and I would subtract 6 from it squared. So this graph is the mother function shifted 6 spaces to the right, and I did minus 6. However, if I want this to shift to the left, right? So let's reset it to its original position because that's where what all of these are. They all begin in the original position at the where the vertex is on the origin. If I want to shift 3 spaces to the left, 1, 2, 3, I want it here. Okay. I want it to move 1, 2, 3 spaces. Then my formula, again, I got to get inside X's head and I got to say, hey, I want you to move to the right 3 spaces. Excuse me, to the left 3 spaces. So it just feels so uncomfortable to put a plus when I want to go left, to put a minus when I want to go right, but this is what's going to catch you, okay? So be careful with that. All right, so now we finished talking about shifting to the left and the right. Let's now talk about shifting up and down, okay? I want to go up and down. So how do I change my function in order to move up and down? Well, if you remember, we have been talking a lot about that linear equation y equals mx plus b, where the b is the y-intercept. And we argue all the time. I'm like, this is not the y. This is the y-intercept. This is the y-intercept. Y-intercept. Not the y. It is still the y-intercept. So the original mother function starts at the vertex of 0. It crosses the y-intercept at 0, which means there's no need to write that. I don't need to write plus 0. If it's nothing. It's not there. But when I want to move this graph, shift this graph up 1, 2, 3, 4, 5, right? I need to say that I want it to cross the y-axis at 5. I want to shift from 0 up 5. So I would just add the plus 5. And in this case, it's straight up. If I want to go up 5, I put plus 5. And even though this is not the y, guys, we're going to think of the y-axis as the guy. And we're going to move and just keep it straightforward. Like, hey, I want to go up, it's 5. So, of course, if I want to go down, then it's minus. So this one would be f of x equals x squared minus 1. And this minus 1 is the y-intercept. And that's telling me to move the graph down from the vertex 1. Okay, so that's shifting up and down. Okay, that's a vertical shift and a up and down. All right. Now, let's move on from that and let's get back to affecting this graph in other ways. We can actually make this graph wider, or so often you'll see wider, but you might also see compress. Okay, so what do I mean by compress? Let's look at, oh, I wish I was more prepared, a balloon. If I push down on this balloon, if I press down on the balloon becomes wider, correct? So if I compress, if I push down on this parabola, I'm compressing it, I'm pressing down, this parabola will become wider. So there are times when you will see this parabola will go, let me think of the math real quick. So if I had like this, like this, it would be the same on the opposite side because of the vertex. And it starts still from here, but now you'll notice it's wider. Okay, so what makes it wider? Well, if I take that x squared and I half it, for instance, then when I insert 2 into the in for x, 2 squared is 4, half of 4 is 2. So I would have a 2.12. Cheapers. If I have 2 squared, I get 4. I knew I did this wrong. Darn it. And this is too far in for me to redo the whole thing. So, oops. That's why you got to check your math, right? Yeah. It would be 2, because 1 squared is 1. 2 squared is 4. All right. I would have 4 squared, which is still 16, and 3, 4, 5, 6, 7, 8, half of that, and 4, 8. So if I put in 4 here, 4 squared is 16 divided by 2 is 8. Okay, so now when I draw this little bad boy here, still wider, but just more accurate, right? The way you make a parabola wider is you choose values for A that are between 1 and -1. So all of these values can be A, any of them. And if it's here, right? So if I have 1/4, if I have 1/3, if I have 5/6, if I have 7/8, if I have 1/100th, all of them, if I have -1 and 100, if I have negative 6/7. As long as what they are equal to is less than or between -1 and 1, I will get a chunky parabola. Okay, it'll get wider. I have compressed it. All right. Now, however, I can take that same parabola and I can make it skinny, narrower, or I can stretch it. Okay, this is the upscale vocab word. Sometimes you'll see narrower. In your mind, you'll think skinny. All right. So if I'm stretching, if I take that same balloon and I start pulling it, I start stretching it up, then it starts to get skinnier. And so that's what we do here when we are working with this problem. If we start to pull it further up, we can get it to be skinnier. So for instance, here we go. Here we go. Okay, so one particular instance, oops, missed the dot, would be like this. And that's if I take it and I make it increase twice as fast. Okay, so before I made it increase half as fast. So it didn't speed up, it took its time going up. Now I'm making it increase twice as fast. So it's going to get up there faster, which is going to make it skinnier. All right. And the reason why, if I put 1 for x, 1 squared is 1 times 2 is 2. So I got 1, 2. But if I put 2 for x, 2 squared is 4 times 2, that's 8. It jumps up really quickly. All right. So that's how it would stretch. So any a that is outside of the -1 and the 1, then that would make it a skinnier graph. So sometimes they try to be tricky. They might give you a fraction like 5/3. 5/3 is larger than 1, right? It would be over here, so you would still get a skinny graph. So think of it as a fraction is helpful, but it's not exact. You need a fraction that is in between, or a decimal or a value that is in between -1 and 1. But if you have a fraction and it's greater than 1, or if it was negative, it's less than -1, but it's on this side of it, it's still going to give you a skinnier fraction. All right, so the next video will be about combination transformations.